Hello everyone, welcome to Design Your Thought, where we simplify complex tech concepts for you. In today's video, we will break down 11 fundamental system design concepts that every software engineer should know, from scalability to load balancing, from caching to database sharding. We will cover it all with real-world examples and easy-to-understand explanations. Whether you are preparing for an interview or just want to level up your system design skills, this video is for you. Let's start.
Vertical scaling means upgrading or adding more power to a single machine to handle more work. Think of it like upgrading your computer, adding more RAM, a faster processor, or bigger storage. If you don't need huge scaling, adding more resources to one machine can be cheaper. But at some point, you can't keep upgrading one machine forever. Horizontal scaling means adding more servers to our system to handle more work instead of upgrading a single machine. We can use horizontal scaling in case of large-scale systems when our service has so many users that one server cannot handle it all. It improves reliability because if one server is down, other can easily take over. It also adds flexibility. We can remove or add servers on demand. When the user increase, we can add servers, and when user decrease, we can remove servers. In case we have to run a website of millions of users like Facebook, YouTube, instead of having one super powerful server, we may add many smaller servers that work together. This approach can help handle more traffic and is more fault tolerant. Load balancer is a tool that distributes network or application traffic across multiple servers. Its purpose is to ensure that no single server becomes overwhelmed, which improves performance, scalability, and reliability. In case of traffic distribution, load balancers use different types of algorithms, which causes different types of load balancers like round robin, least connections, IP hashing, and many others. Load balancer redirects traffic from failed servers to healthy ones, which ensures the application or the system remains available. Load balancer helps handle increased traffic by distributing load efficiently within allocated servers. It improves performance and also helpful in case of health monitoring of different servers. When someone visits a website, instead of fetching content from the main server, the CDN delivers it from a server that is geographically closer to the user. CDN is a network of servers distributed around the world that helps deliver content to users faster and more efficiently. For example, if you have a website hosted in New York but users are in India, without a CDN, the request would go all the way to New York, causing delays. With a CDN, a server in India would deliver the content, making it much faster. In a distributed system, a cache is a temporary storage used to store frequently accessed data closer to application or user. The goal is to improve performance, reduce latency, and minimize the load on backend systems. When a client requests data, the system first checks the cache to see if the data is already stored there. If the data is not in the cache, it is fetched from the backend or database, returned to the client, and stored in the cache for future requests. Distributed caches must ensure that cached data stays in sync with the original source, especially for frequently updated data. From the subsequent requests, the data will be fetched from the cache. It improves performance, reduces latency, and decreases load on backend servers.
TCPIP is a set of communication protocols used to connect devices on the internet. Here, IP address figures out a path and address where to send the data, and TCP ensures the data delivery is correct, in order, and without errors. Data is divided into packets, so large data is broken into some smaller chunks. Each packet gets a sender and receiver's IP address. These may take different routes to the destination. TCP reassembles the packets in the correct order and ensures no data is lost. TCP ensures reliable delivery and no data is lost. Sharding is a way of splitting up large amounts of data into smaller and more manageable pieces. These pieces are named as shards. Each shard contains a subset of the data, and together all the shards make up the entire dataset. Data is divided based on sharding key. It could be user ID, region, or some other property. When a request is made, the system uses the sharding key to identify which shard contains the required data and retrieves it. Sharding improves scalability of a system. It also improves performances because each server handles a small portion of the data. It reduces single points of failure. If one shard goes down, it doesn't affect other shards, which makes the system more resilient. If we have an e-commerce site with millions of users, instead of keeping all user data in one massive database, we can divide the data based on region or based on user ID. In that case, it will improve the data retrieval process of the project. Master-slave architecture is a design pattern commonly used in system design. Here, the master handles coordination, decision-making, or distributing tasks, while the slaves follow its instructions and perform specific tasks. In a database setup, the master handles writing the data changes like insert, update. The slaves replicate data from the master and handle read operations, providing faster access for users querying data. This term is increasingly being replaced with terms like primary replica or leader-follower in modern systems. Polling is a process in which a system repeatedly checks or requests data from a server at regular intervals to see if there is new information or a specific condition has been met. A client sends a request to the server asking for data. The server responds either with the requested data or indicating no new data is available. The client repeats this process periodically based on an interval. This is how polling works. In case we don't have any push-based mechanisms, we can use polling. In simpler systems with occasional updates where efficiency isn't a major concern, we can use polling. Alternative to polling are systems like push notifications, WebSockets, server-sent events. CAP theorem is a concept in distributed systems that states a distributed system can only guarantee 2 out of 3 properties at the same time. The 3 properties are consistency, availability, and partition tolerance. Consistency is when all the nodes see the same data at the same time. In case of banking, after transferring money, new balance should be instantly visible on all systems. Availability is when if one server is down, other servers can still process requests. And partition tolerance means the system continues to function even when network failures occur between nodes. Trade-off is you must choose 2 out of 3 based on your use case. One is CP, consistency and partition tolerance. System always returns the most recent data but may sacrifice availability during network issues. In case of banking or stock trading apps, AP is availability plus partition tolerance. Here, system is always available even during network issues, but data may be outdated. In case of social media and online shopping apps, this kind of system can be implemented.
The third one is consistency and availability. This is possible only in case of non-distributed systems. In distributed systems, it can't be possible. A Msg Q is a system used to send, store, and manage messages between different parts of an application. It ensures they are delivered reliably even if the sender and receiver are not active or connected at the same time. Msg Q decouples components, improves scalability, handles asynchronous processing, and enhances reliability within the system. Common use cases includes task scheduling, load balancing, real-time systems like chat apps, and event-driven architecture.
That's it for today. I hope you found these concepts helpful. If you did, don't forget to click the like button and hit subscribe. And I'll see you in the next one. Bye.